Question 7. Given that k belongs to the set of positive integers, so that's what that z plus means, positive integers, show that the integral of 2 divided by 3x subtract k with respect to x between the limits 3k and k is independent of k. Now what that's effectively saying is once we get our answer out, hopefully k is going to disappear. If we remind ourselves of this idea that the integral of the derivative of a function, the original function, this is where we get a natural log. So because if you differentiate the natural log of a function, because of the chain rule, you get the derivative of the original. Integrating, we get this. Now if we look at the derivative of 3x subtract k, so if you differentiate 3x subtract k, you would just get 3. Now on the top we have 2, so that means that effectively our answer can be 2/3 of the natural log of our denominator. So 3x subtract k, integrate with respect to x, is going to become 2/3, because if it was a 3 on top it would be the whole thing, the natural log of 3x subtract k. And because we've got our limits, square brackets, 3k, k. So now we're going to put our limits in and hopefully everything will cancel out. So we're going to sub 3k in there first. 2/3 the natural log of 3 times 3k subtract k. We're going to subtract 2/3 times the natural log of 3k subtract k. What are these going to simplify to? So we're going to get 2/3 of the natural log of 8k subtract 2/3 the natural log of 2k. So I could have done this earlier actually, but if I factorize out that 2/3, you've got the natural log of 8k subtract the natural log of 2k. Now our rules of logs mean that when we have a logarithm subtract a logarithm, we can actually use division here. So this is going to be 2/3 of the natural log of 8k divided by 2k. 8k divided by 2k is 4, so we get 2/3 the natural log of 4. Notice that our k has disappeared, it's gone. Our answer is independent of k. So this shows us our solution is independent of k. In question 7b, we need to show that the integral of 2 divided by 2x subtract k all squared with respect to x between the limits 2k and k is inversely proportional to k. So inversely proportional, so remind ourselves from GCSE maths, and what does inverse proportion mean? So if, for example, a was inversely proportional to k, we would say a is proportional to 1 over k. And then you could turn that into an equation by bringing in a constant. We actually normally use k, so if I use c, we could say it's c over k. Or you could say it's maybe c multiplied by 1 over k. So if we can get an answer in this sort of format, then we will have shown that. So using our rules of negative indices, we can actually rewrite our integral as the integral of 2 multiplied by 2x subtract k to the power of negative 2. So it's this rule that we've got. So say, for example, a to the power of negative 2 is 1 over a squared. And then we can integrate that using reverse chain rule. So because the function 2x subtract k is a linear function, that means that we can integrate it as if it was sort of in the form x to the power of n. So add 1 to the power, divide by the power. We just have to remember to divide by the derivative. So the derivative of 2x minus k is just 2. So we've also got to remember to divide by 2. It's called reverse chain rule because if you were differentiating, you would multiply by 2. So let's put this into practice. So what we're going to do is we're going to add 1 to the power. So you're going to get 2x subtract k to the power of negative 1. And then we're going to divide by negative 1. We're also going to divide by 2. So that's going to cancel out this 2. So we have negative 2 over 2, and these are going to cancel out, and our limits will stay the same. So let's put our limits in. So I'm going to use a big square brackets. We've got negative, and then we've got 2 multiplied by 2k, subtract k, all to the power of -1. And then we're going to subtract, so negative, so we're going to do 2 times k, subtract k, and that's all to the power of -1. So let's simplify this. So we've got 4k, subtract k, so that's 3k. 3k to the power of -1 will be 1 over 3k. We're going to get -1 over 3k. And then we're going to have 2k subtract k is k. K to the power of -1 is 1 over k. So we're going to get -1 over k, but we've got the double negative, so it's going to be plus 1 over k. So we can actually add these together, use our rules of the common denominator, add fractions. So we could say it's -1 over 3k plus 3 over 3k. And that gives us 2 over 3k, or if you like, 2/3 multiplied by 1 over k. So let's just write that. I'm going to call the integral I, so I can save a bit of ink. So this implies that I is proportional to 1 over k, or is inversely proportional to k. Happy day, so that's 7 marks in the bag for question 7.